Imagine a little boy sitting alone by a window. Outside, children are laughing, running through dusty streets, filling the afternoon with cheerful noise. But this boy barely speaks. Many adults quietly wonder if something is wrong with him. Some even believe he may never become successful. Not his teachers, not his neighbors, not even the greatest scientists of the age could imagine that inside this silent child lived ideas powerful enough to reshape the universe itself. Years later, the world would know his name, Albert Einstein. His face would become one of the most recognizable images in history. His discoveries would unlock the secrets of space, time, gravity, energy, and light. His famous equation, E=mc², would forever change science. Yet the greatest mystery was never just the universe. It was how an ordinary, quiet child became the man who changed humanity's understanding of reality. Tonight, we travel back through time, into 19th century Europe, into classrooms where curiosity was misunderstood, into lonely walks beneath endless skies, into thought experiments that required no laboratory, only imagination. This is not simply the story of a scientist, it is the story of wonder itself, and perhaps, by the end, you will see the universe and yourself in a completely different way. To understand Albert Einstein, we must first understand the world into which he was born. The year was 1879. Europe was transforming at breathtaking speed. Factories stretched across cities, steam engines connected nations, electricity was beginning to illuminate streets that had once belonged only to darkness. The Industrial Revolution had changed everyday life. Science seemed unstoppable. Isaac Newton's laws had ruled physics for nearly 200 years. Scientists believed they understood almost everything important about the universe. Nature appeared to operate like a perfectly designed clock. Every movement could be predicted, every force could be calculated, every mystery seemed close to being solved. Yet beneath this confidence, invisible cracks had begun to appear. Light behaved strangely, electricity refused to follow simple explanations, tiny particles puzzled researchers, questions emerged that no one could answer. It was as though the universe itself was whispering, "You have only begun." Meanwhile, Germany was becoming one of Europe's leading centers of engineering and scientific education. Universities flourished, innovation-filled workshops and laboratories. It was a nation fascinated by precision, discipline, and technology. No one knew that one quiet child growing up among these changing cities would soon challenge every assumption science had built over centuries. Albert Einstein entered the world on March 14, 1879, in the small German city of Ulm. His parents, Hermann and Pauline Einstein, welcomed their first child with hope for an ordinary future. Nothing about his birth suggested greatness. His father managed an electrical business. His mother loved music, especially the piano. Their home was modest but filled with warmth. As Albert grew older, however, something unusual became apparent. He spoke very little. Some family members worried. Stories later spread claiming he could barely talk until age 4. Although historians debate the exact details, everyone agreed he developed language more slowly than many children. His quiet nature caused concern. Teachers misunderstood his silence. They often mistook deep thinking for lack of intelligence. Albert disliked memorization. He disliked strict rules. He asked questions that adults often found irritating. Instead of accepting answers, he demanded explanations. Why, how, what if? These simple questions would shape his entire life. One afternoon, when Albert was about 5 years old, his father handed him a small magnetic compass. It looked like an ordinary object, yet it changed everything. Albert noticed something astonishing. No matter how he turned the compass, the needle always pointed north. No visible hand pushed it, no string moved it, something invisible controlled its motion. Years later, Einstein would remember this moment as one of the greatest experiences of his childhood. He realized that unseen forces filled the universe. Reality was far stranger than it appeared. That tiny compass awakened a lifelong fascination with invisible mysteries. Sometimes the smallest objects open the largest doors. School was not easy for Albert. His classrooms emphasized obedience. Students memorized facts. Teachers expected silence. Creativity rarely received praise. Albert struggled within this system. He respected knowledge but disliked authority without reason. One teacher reportedly told him he would never amount to anything. Whether those exact words were spoken remains uncertain, but it is true that many educators believed he lacked discipline. Ironically, discipline was never the problem. His curiosity simply traveled in directions the classroom could not follow. Outside school, Albert found freedom. He spent hours reading mathematics. Geometry fascinated him. Numbers seemed to reveal hidden truths about nature. Unlike memorized lessons, mathematics felt alive. Every equation became another piece of the universe's language. His uncle introduced him to advanced mathematical ideas far beyond his age. Soon Albert solved problems that amazed adults. Music also became part of his life. His mother encouraged violin lessons. At first he resisted. Later, he fell deeply in love with Mozart. Whenever scientific problems overwhelmed him, he often played the violin. The music helped organize his thoughts. Many of his greatest ideas emerged after long evenings of quiet melodies. Science and art became partners inside his mind. One explained the universe, the other allowed him to feel it. Eventually, financial troubles forced the Einstein family to move from Germany to Italy. Albert remained behind briefly to finish school, but he disliked the rigid education system so intensely that he eventually left, without completing the traditional path. He joined his family. For many, this decision would have ended academic dreams. For Albert, it became the beginning of an extraordinary journey. The image stayed with Albert Einstein for years. Imagine a man falling freely from the roof of a tall building. As he falls, everything around him seems to float beside him. For a brief moment, gravity appears to disappear. To most people, it is only a strange thought. To Einstein, it became the key to unlocking one of the greatest mysteries in science. He later called it the happiest thought of his life. That single idea would eventually transform our understanding of gravity, space, and even the universe itself. After the miracle year of 1905, Einstein was no longer an unknown patent clerk. Universities across Europe began to recognize his extraordinary mind. He accepted teaching positions in Zurich, Prague, and later returned to Zurich before finally moving to Berlin in 1914. His reputation grew quickly. Scientists admired his bold ideas. Students traveled long distances simply to hear him speak. Yet Einstein was not satisfied. Special relativity explained how the universe behaved when objects moved at constant speeds. But one great force remained unexplained: gravity. For more than 2 centuries, Isaac Newton's theory of gravity had guided science. It worked remarkably well. It explained why apples fall, why planets orbit the sun, and why the moon circles Earth. But Einstein believed something deeper was hidden beneath Newton's equations. For nearly 10 years, he struggled. The mathematics became incredibly difficult. Many times he doubted himself. Friends later recalled how exhausted he often looked, his notebooks filled with crossed-out equations and failed attempts. Still, he refused to give up. Then, in 1915, everything came together. Einstein introduced the general theory of relativity. Instead of describing gravity as an invisible force pulling objects together, he proposed something astonishing. Space and time formed a single, flexible fabric called space-time. Massive objects like stars and planets bent this fabric. Other objects simply followed those curves. Imagine placing a heavy bowling ball on a stretched rubber sheet. The sheet bends under its weight. Now roll a small marble nearby. The marble naturally curves toward the bowling ball, not because the ball pulls it directly, but because the surface itself has changed. Einstein believed the universe worked in much the same way. The sun bends space-time. Earth follows that curved path. What we call gravity is actually the geometry of the universe. It was an idea almost impossible to imagine, yet it explained nature with breathtaking elegance. A scientific theory, no matter how beautiful, must survive one final test. Evidence. Einstein predicted that gravity would bend light itself. According to his calculations, light passing near the sun would appear slightly shifted. The only opportunity to observe this effect would come during a total solar eclipse. In 1919, British astronomer Sir Arthur Eddington organized expeditions to observe one. Teams traveled thousands of miles to remote locations, carrying delicate telescopes across oceans and through difficult conditions. The world waited. When the eclipse arrived, the measurements revealed something extraordinary. The stars appeared exactly where Einstein's equations predicted they would. Light had indeed bent around the sunday. Newton's view of gravity was no longer complete. Einstein's theory had passed its greatest test. Within days, newspapers around the world announced the astonishing news: a revolution in science, a new theory of the universe. Almost overnight, Albert Einstein became the most famous scientist on Earth. His wild hair, thoughtful eyes, and gentle smile became symbols of genius. People who had never opened a physics book knew his name, yet fame changed very little about him. He remained humble, curious, more interested in questions than in applause. While Einstein's ideas united scientists, the world itself was becoming deeply divided. The First World War had left Europe wounded, entire cities had been destroyed, millions of lives had been lost. Einstein became a strong advocate for peace. He believed that knowledge should unite humanity rather than divide it. But darker times were approaching. In the early 1930s, Adolf Hitler and the Nazi Party rose to power in Germany. As a Jewish scientist, Einstein found himself in increasing danger. Books written by Jewish authors were burned. Universities were transformed. Hatred spread rapidly across the nation. Einstein was traveling abroad when Hitler became chancellor in 1933. He realized returning to Germany would be unsafe. He never went back. Instead, he accepted a position at the Institute for Advanced Study in Princeton, New Jersey. America became his new home. There, surrounded by quiet streets and academic buildings, Einstein continued exploring the mysteries of the cosmos. Yet even from across the Atlantic, he watched Europe descend into another devastating war. One of the greatest ironies of Einstein's life emerged during World War II. Einstein himself was a committed pacifist. He deeply opposed violence. However, many scientists feared Nazi Germany might develop an atomic bomb first. In 1939, Einstein signed a letter to U.S. President Franklin D. Roosevelt. The letter warned that uranium could potentially be used to create an extraordinarily powerful weapon. It encouraged the United States to begin serious research before Germany did. That letter helped inspire what later became the Manhattan Project. Although Einstein did not work on the project itself and had no direct role in building the bomb, his famous equation, E=mk², revealed the immense energy hidden within matter. When atomic bombs were dropped on Hiroshima and Nagasaki in 1945, the world entered the nuclear age. Einstein was deeply saddened. He later expressed regret that his warning letter had contributed, even indirectly, to the chain of events that led to nuclear weapons. From that point onward, he became an outspoken advocate for nuclear disarmament and international cooperation. He reminded humanity that scientific knowledge alone could never guarantee wisdom. The future, he believed, depended on how people chose to use that knowledge. Despite his extraordinary intellect, Einstein was surprisingly ordinary in many ways. He loved sailing, even though he was not particularly good at it. Friends joked that he often became lost on the water, smiling calmly while others worried. He disliked wearing socks and often went without them, claiming they wore out too quickly. His untidy hair became legendary, and not because he wanted attention, but because appearance mattered little compared to ideas. Children adored him. He answered letters from young students with kindness and patience. Unlike many famous figures, Einstein never wanted to appear superior. He believed curiosity belonged to everyone. Many legends grew around him. Some claimed he failed mathematics as a child. This story is false. In reality, Einstein excelled in mathematics from a young age. Others believed genius arrived suddenly in a single moment. The truth was very different. His greatest discoveries came after years of persistence, countless mistakes, and endless questioning. Perhaps the greatest lesson from Einstein's life is not that he was born different, it is that he never stopped wondering. And as his fame spread across the world, one final mystery began to capture his imagination, a mystery so vast that it stretched beyond stars, galaxies, and even time itself. The mystery of the universe is beginning. The deeper Albert Einstein explored the universe, the more mysterious it became. Every equation answered one question only to reveal 10 more. Beyond the stars, beyond the galaxies, beyond even space and time, new mysteries waited patiently. Einstein understood something that many people forget. The greatest discoveries are not the end of curiosity. They are only the beginning. By the 1920s, Einstein had become the most celebrated scientist alive. Universities invited him to speak. World leaders sought his advice. Newspapers followed his travels as though he were a movie star. Yet he remained focused on understanding nature. His theories transformed nearly every branch of modern physics. Special relativity revealed that time is not fixed. A clock aboard a fast-moving spacecraft ticks differently from one on Earth today. This is not just theory, it is measured every day. Satellites in orbit experience time differently because of both their speed and Earth's gravity. Without correcting for these tiny differences, GPS navigation would drift by several kilometers each day. General relativity changed astronomy forever. It predicted that massive stars could collapse into invisible objects with gravity so powerful that even light could not escape. Decades after Einstein proposed his equations, scientists gave these objects a name: black holes. He also predicted that enormous moving objects would create tiny ripples in space-time itself. These became known as gravitational waves. For nearly 100 years, no one could detect them. Many wondered whether they truly existed. Then, in 2015, enormous detectors measured an almost unimaginably small vibration passing through Earth. Two distant black holes had collided over 1 billion light-years away. Einstein had been right once again. His equations had described a universe no telescope of his own time could ever observe. Ironically, one of Einstein's greatest mistakes became one of modern science's greatest discoveries. When he first applied general relativity to the universe as a whole, the equations suggested that the universe should either expand or contract. But nearly everyone believed the universe was eternal and unchanging. To keep it static, Einstein introduced an extra mathematical term called the cosmological constant. Years later, astronomer Edwin Hubble observed something extraordinary. Distant galaxies were moving away from us. The universe was expanding. Einstein reportedly called the cosmological constant his greatest blunder. Yet history had another surprise waiting. In the late 20th century, astronomers discovered that the universe is not only expanding, it is expanding faster over time. To explain this mysterious acceleration, scientists once again turned to the cosmological constant. Today, many researchers believe it may be connected to dark energy, an invisible force that appears to make up most of the cosmos. Even Einstein's so-called mistake may have pointed toward one of the greatest mysteries in existence. Despite everything he achieved, Albert Einstein spent the final decades of his life chasing one last dream. He wanted to discover a unified field theory. His hope was breathtakingly simple. He believed that every force in nature, gravity, electricity, magnetism, and the forces inside atoms might be different expressions of one elegant law, a single equation, one complete description of reality. Day after day, he walked through the quiet streets of Princeton carrying sheets of paper covered in calculations. Colleagues often saw him deep in thought, speaking softly to himself. He searched tirelessly, but the answer never came. Even today, scientists continue that search. Modern theories such as string theory and loop quantum gravity attempt to unite Einstein's ideas with quantum mechanics, yet no theory has fully succeeded. Perhaps the universe still guards its deepest secret, or perhaps the answer awaits another curious child looking through a classroom window. Einstein himself had doubts about quantum mechanics. Although he helped lay its foundations, he struggled to accept its strange unpredictability. His famous remark, "God does not play dice," reflected his belief that nature must follow deeper hidden laws. Today, experiments strongly support quantum mechanics, yet the debate about its true meaning continues. Some of the greatest questions Einstein asked remain unanswered. What happened before the Big Bang? What is dark matter? What is dark energy? Can gravity and quantum physics finally become one? The quiet boy who transformed science left behind mysteries that still inspire generations of researchers. Albert Einstein received the Nobel Prize in Physics in 1921, not for relativity, but for explaining the photoelectric effect, a discovery that helped create the technology behind modern electronics. His influence reached far beyond laboratories. He spoke against racism. He supported civil rights. He welcomed refugees. He believed education should encourage imagination instead of fear. He once said, "Imagination is more important than knowledge, for knowledge is limited, whereas imagination embraces the entire world." Those words continue to inspire scientists, artists, teachers, and dreamers alike. Einstein's image became a universal symbol of genius, but those who knew him best remembered something else: his kindness, his humility, his endless curiosity. He never claimed to have all the answers. Instead, He believed that asking beautiful questions was one of life's greatest gifts. On April 18, 1955, Albert Einstein passed away in Princeton, New Jersey, at the age of 76. The man was gone, but his ideas continued traveling across the university through classrooms, observatories, spacecraft, laboratories, and the minds of millions. Perhaps the most remarkable thing about Albert Einstein is not that he changed science, it is that he never stopped being curious. As a child, he stared at a tiny compass and wondered about an invisible force. As an old man, he looked toward the stars and wondered whether humanity had only begun to understand reality. Between those two moments lay one of the greatest intellectual journeys in history. His life reminds us that genius is not merely about intelligence, it is about patience, it is about courage, it is about asking questions that others overlook. Every star above us, every galaxy beyond our sight, every ray of light crossing billions of years of darkness, every second that quietly slips into memory, they all exist within a universe more mysterious than we can fully imagine, and perhaps that is the greatest lesson Albert Einstein left behind. The universe is not a puzzle waiting to be finished, it is an endless invitation to wonder. So tonight, as you look up at the night sky, remember the quiet boy who once believed that imagination could travel faster than fear, a boy who asked impossible questions, a man who changed the universe, and a legacy that reminds us all that the next great discovery may begin with something as simple as a child asking, "Why?" Thank you for joining us on this journey through the extraordinary life of Albert Einstein. If you enjoyed this documentary, don't forget to like the video, subscribe to the channel, and turn on notifications so you never miss another story from history's greatest minds. Until next time, keep wondering, keep learning, and never stop looking up at the stars.